In this IXL, we're going to be taking the absolute value of complex numbers. So here are the notes for it. So here's a complex number. Just ignore the absolute value for a moment. We've got a complex number here. It's got the real component and it's got the imaginary part of it. So the real part is -6 and the imaginary part is -8i. In order to take the absolute value of this, I actually do a Pythagorean theorem. I take the real part and I square it, and I take the imaginary part and square it. I add them together and I take the square root. If you're in my class, I would call this like a square add type of problem. Now, I'm going to take 6 squared and 8 squared. And you're asking me, hey, Mr. Barr, it's really -6. Why aren't you including the negative? And I'm saying, I'm not including it because when it squares, it's going to go away anyways. So I'm not even thinking about the negatives. So yes, it's a -6. Yes, it's a -8. But because of the squaring, it doesn't even matter. So 36 plus 64, that's 100. Square root of 100 is 10, which means the absolute value of -6 minus 8i is 10. So let's do one of these. Now the first ones are actually simpler than this because the real part and the imaginary part are, there's no real part to this. So if I was just following my notes, real is 0 squared, imaginary is 10 squared. So this is the square root of 100, which is 10. Here, it's the same idea, so it's just going to be 6, right? 6 squared, square root of 6 squared. This one is just 3. 3 squared is 9. Square root of that is 3. And now we're actually getting into what I just taught you. So I take 3 squared, so 3 squared plus 4 squared. That's 9 plus 16, that's 25. Take the square root of it, it's 5. So this is going to be 6 squared plus 8 squared, that's 36, plus 64, which is 100. Square root of 100 is 10. Four squared plus 3 squared, that's 16 plus 9, that's 25. Square root of that is 5. Something is going to happen up here in a moment. Actually, it's happening right now. So this is going to be 2 squared plus 1 squared, that's 4 plus 1, which is 5. The square root of 5, well, this would turn into some kind of a decimal, right? Something in the realm of 2 point something. The thing is, it's not talking to me about rounding at all. Like if I did square root of 5, that's 2.236. But it's not talking about rounding anywhere. It actually, and look, it's giving me the square root button. So it's actually going to go in as just the square root of 5. And with that, I've actually given you all the knowledge you need to keep going with this. So this is 6 squared, which is 36, plus 7 squared, which is 49. Adding them together takes me to 85. I'm going to put it in as the square root of 85. And there's no way to make these more challenging. Even if I go to the challenge zone, what? How is this more challenging? It's not. 10 squared is 100, 4 squared is 16, 116, the square root of 116. Done. Nope. Oh, Mr. Barr. Yes. Okay, I guess it doesn't get more complex. I have to simplify that down, and I did not do that because it wants it simplified. 116, that is 2 times 58. 58 is 2 times 25, 6, 7, 8. 28 is 2 times 14. So this is actually 2 square root of 28, which is, 2 square root of 29. That's a 29. I get it. You've got to simplify it down. My error. Let me jump back up to that level. So this is going to be 60, excuse me, 64 plus 100, which is 164, taking the square root of that, have to simplify it. That's 50, 60, 70, 82. 82 is 2 times 41, so it's 2 square root of 41. And I do have a video on that. There we go. And I'll do one more, and then we'll call it good. So 64 plus 4, that takes me to 68, square root of 68. Let's see, how does that break down? 68 is 2 times 34, which is 2 times 15, 16, 17. So it's 2 square root of 17. All right, that's it. Thanks for watching.